bypass ratio is defined as mass of the bypass divided by mass of the core. Another way of describing this is bypass mass flow over high pressure compressor mass flow. Here's some bypass ratio for some engines and the aircraft that they're used on. If we look at pure turbojets, like the Rolls-Royce Snecma Olympus 593, which was used on Concorde, it's a pure turbojet. There is no bypass. The bypass is 0 to 1. It's all going through a hot core. And as we move up through the aircraft, all the way through, let's just pick on the early 737s, JT8Ds, Pratt & Whitneys. It was more or less a 1-to-1 bypass ratio. So it says there 0.96 to 1, nearly the same amount going outside as through the central core. As we progress up to Rolls-Royce Trents 900s on the A380 or the General Electric on 787, we're getting bypass ratios of 8.1, 9 to 1 and 10 to 1 accordingly. And if we look at the Pratt & Whitney PW 1000G on the Bombardier C series, bypass ratios of 12 to 1, meaning 12 amounts of air are going outside, cold air so to speak, rather than one lot of air which is going through the central core. So it's almost like they're becoming like propeller driven aircraft again, and they're really called turbo fans. So let's have a look at some bypass ratio formulae. Bypass ratio is defined as mass of the bypass, that's what's going outside, divided by the mass of the core. It's the flow of air we're talking about really. So bypass ratio could also be described as bypass mass flow divided by the high pressure compressor mass flow. So other ways of thinking about this would be bypass mass flow equals the inlet mass flow minus the high pressure compressor mass flow. And the HP compressor mass flow equals the inlet mass flow minus the bypass mass flow. So this is just by rearranging formulae. Let's look at a question. A turbofan engine with an inlet air mass flow of 1000 kilograms per second and a high pressure compressor mass flow of 111 kilograms per second would have a bypass ratio of what? Let's look at the formula. Bypass ratio equals bypass mass flow divided by high pressure compressor mass flow. Bypass mass flow is inlet mass flow minus high pressure compressor mass flow. Bypass mass flow has to be calculated by subtracting 111 from 1000 kilograms per second to get 889 kilograms per second. So the bypass ratio is 889 kilograms per second divided by 111 kilograms per second, resulting in a bypass of 8.01 to be precise. Quite a high bypass. Here's another example. A twin spool engine with an inlet air mass flow of 220 kilograms per second and a high pressure compressor mass flow of 220 kilograms per second has a bypass ratio of. Well, you should kind of see this instantly. What's going through the inside is the same as the total flow. So let's look at the formula. The bypass ratio equals bypass mass flow divided by high pressure compressor mass flow. And bypass mass flow equals inlet mass flow. The inlet mass flow is 220 kilograms per second. And from this, you subtract 220 kilograms per second, which is the high pressure compressor mass flow, giving a result of 0 kilograms per second for the bypass mass flow. Going back to the bypass ratio formula, the bypass mass flow is 0, and the HP compressor mass flow from the question is 220 kilograms per second, so the bypass ratio is 0, which is the point I was trying to make from the question. You could see with the two numbers being the same there that this essentially is a turbojet with no bypass.